All right, today we are going to look at 10.2. So this video looks at 10.2. We're going to talk about probability, multiplication, and addition rules of probability as well. So just a reminder, probability is the likelihood of an event. We're just going to read through some of this. Probability is the likelihood of an event. It can be expressed as a fraction, decimal, or a percent. Probability always stays between 0 and 1 when we write it as a decimal. It's between 0% and 100%. Probability of 0 means that an event is impossible. It can't happen. Probability of 1 means that the event has to happen. It is certain to occur. What we also need to remember is the basic definition of probability right here. Probability of an event A happening is equal to the total number of favorable outcomes divided by the total number of possible outcomes. And that's why we talked about events and Venn diagrams, sample spaces, so that we could count the total number of favorable outcomes and total number of possible outcomes. All right, so independent events. We're going to talk about independent versus dependent. So independent events are events that don't affect each other's outcomes. So two events are independent if the outcome of one is unconnected to the outcome of the other. So the occurrence of one doesn't change the probability of the other. So for example, two coin flips. If you flip a heads in the first flip of that coin, that does not affect the outcome of the second flip. If you flip heads the first time, probability of heads the second time is still 1/2. Two rolls of a die, flipping a coin and rolling a die that don't affect each other. And you can read through that. Important idea right here, drawing things from separate containers or selecting two items and then replacing the first item before the second one is selected. Those are independent events. And you can read through the rest of that. Dependent events. Two events are dependent if the outcome of one affects the outcome of the other, if they're somehow linked together. So the occurrence of one event changes the probability of the other event. Okay, so independent, they do not affect each other. Dependent, the outcome of the first or the outcome of one of them affects the outcome of the other. And an example of that would be selecting two items without replacement. For instance, if you have a bag that has blue and green marbles, if you draw a green marble and you don't replace it, the probability of drawing another green changes on the second draw. So selecting two items, first not returned, so we say without replacement. Okay, dependent events. And you can, again, read the rest of that. So we're going to go ahead and dive into some examples. Actually, we have one other idea. Often it's hard to tell whether two events are dependent or independent, and we will talk more about that in the section 10.3. For example, studies are often conducted to figure out if taking a medication affects recovering from a disease. There are lots of different studies between events to see if they're independent or dependent. Okay, so the probability of an event, probability of two independent events. So this is an important idea right here. Independent events. We have two independent events, A and B. The probability of A and B happening is the product of A times the product of B. Remember that intersection symbol is an and. So the probability of A and B, so this is an and, probability of A and B equals the probability of A times the probability of B if the events are independent. So underline that word independent, if they're independent. This is called the multiplication rule of probability because it's multiplication. All right. And we're going to do some examples. In a board game, each player has 3 different colored markers. To move around the board, the first player spins a spinner, like the one over here at the right. The colors, the 3 different colors must be red, yellow, and blue. The player first spins a spinner to see which piece can be moved. The player then rolls a die to determine how many spaces that colored piece should move. Remember, if it doesn't say how many sides the die has, then we assume it's 6. On a given turn, what is the probability that, I can take out one of those extra that's, what is the probability that a player will be able to move the yellow piece more than 2 spaces? So the spinner and the die are independent of each other. So we're going to use this multiplication idea, and we're going to say that the probability of, okay, so if we're going to move the yellow piece, then the spinner has to land on yellow. So we need the spinner to land on yellow, and we need to move more than 2 spaces. So we're just going to say greater than 2 spaces. Okay, more than 2 spaces. So since these events are independent, we'll take the probability that the spinner lands on yellow times the probability that the die lands greater than 2. So look at our spinner. The probability of a yellow is going to be 1/3. Each of those spaces, the yellow, the red, and the blue space, they're all the same size. So the probability that lands on yellow is 1/3. Probability of red would be 1/3. Probability of blue would be 1/3. So that probability is going to be 1/3. And then the probability that our die, our 6-sided die, lands on greater than 2. So remember, there are 6 possible outcomes for that die. 1, 2, 3, 4, 5, 6. And greater than 2, there are 4 of those. So that would be probability of the die landing greater than 6, or sorry, greater than 2, is 4/6. Number of favorable outcomes is 4. So here's our favorable outcomes. Total number of outcomes is 6, so 4/6. We can reduce that second fraction to a 2/3. So the probability of yellow and greater than 2 is going to equal 2/9. 1 times 2 is 2, 3 times 3 is 9, so 2/9. Now we're going to practice writing this as a decimal as well. So if we grab our calculator and we do 2 divided by 9, we can change it to a decimal. That's a repeating 2. So it's 0.22. We could just do the 2 with the bar over the top. 0.2 with the bar over the top, or we round it to, let's say, the nearest thousandth. It'd be 0.2222. And then remember how to change a decimal to a percent. We move the decimal point 2 places to the right. So 1, 2. So that becomes 22.22%. So just over 22%. And we will most of the time just leave our answers as reduced fractions. But if you had to, you could change it to a decimal or a percent. Okay, next part. If a die is rolled 3 times, find the probability of rolling a 1 or a 2. So first roll, we want a 1 or a 2. Second roll, we want a 3, so then a 3. And then anything other than 5. So we're going to write it out this way. And the 3 rolls of a die are independent of each other. So we want the probability of a 1 or 2, then a 3, and then anything other than 5. So we'll just say not 5. Okay, so since those events are independent, we will do probability of a 1 or a 2 times the probability that the second roll is a 3 times the probability that the third roll is not 5. Anything other than 5, so just not 5. Okay, the probability of a 1 or 2. Think about that dice again. So we had the dice up above. That little die has 6 possible outcomes. We're going to keep coming back to this. Probability of an event is the number of favorable outcomes divided by the total number of outcomes. A 1 or a 2. That is 2/6. 2 favorable outcomes, 6 outcomes total. Probability of a 3, that's going to be 1/6. And the probability that's not 5 is 5 out of 6. It's not 5, it has to be a 1, a 2, a 3, a 4, or a 6. So that number of favorable outcomes will be 5. Total number of outcomes is 6. We're going to do a little reducing. I'm going to make this first one a 1/3. Okay, so 2/6 is the same as 1/3. I'll just reduce it this way. You okay with that? Well, maybe not. Maybe we won't reduce it that way. So that's 1/3 times 1/6 times 5/6. 1 times 1 times 5 is going to be 5. Grab a calculator. 3 times 6 times 6. 3 times 36 is 108. So as a fraction, it's 5/108. If we changed it to a decimal, I'm just going to round it to thousands. It would be 0. We grab our calculator, we do 5 divided by 108. We're going to round it to 4 decimal places. 0.5 divided by 108. 0.046. My 2 has to round up to a 3. And then if we change that to a percent, it would only be 4.63%. That's pretty small. 4.63%. Odds are not in your favor. Okay. Part C. A fair coin is flipped several times in a row. What is the probability of flipping heads 10 times in a row with a fair coin? And then we'll answer the last question. Actually, we could answer the last question right now. What is the probability of flipping heads on the 11th flip after 10 heads in a row? The answer to that question is going to be 1/2. Because these are independent events. That flip of a coin is independent. We can either write it down now or we can write it down later. Okay, so let's do this. Probability of 10 heads in a row. Heads 10 times. These events are independent, so that probability is going to be the probability that we land heads 10 times, right? And each of those probabilities is going to be 1/2. Oh, I don't really want to write all these down, but I guess I will. There's 4, 5, 6, 7. Oh, this is painful. This is why we use exponents. How many do I have? 2, 4, 6, 8, 9, 10. Okay, all of these say probability of heads. Probability of heads. That's the way we're going to read that. P parentheses H parentheses is probability of heads. So what that's going to be is a 1/2 times a 1/2 times a 1/2 10 times, right? So isn't that 1/2 to the 10th power? Or 1/2 to the 10th power? Or 2 to the 10th power, we grab a calculator, that's 1024. That is super small. Okay, 1/1024. I think it's so small. I could leave it as a fraction, but I'll just write it as a decimal as well. Gives me scientific notation. It's 9.765625 times 10 to the negative 4th power. So if I change that to a decimal, I'm going to approximate it because I'm going to round it to, let's see, 10 to the negative 4th power. That means I need 3 zeros and then a 9, 7, 6. Let's do 5, 6. Where do I want to round this to? I think I'll change it to a percent as well. 0. Decimal has to move 2 places to the right, so 0.09 6. Let's just leave it here. 0.0977%. That's really small. Okay, last thing here. The probability that you roll heads after 10 heads in a row. Okay. That's going to be the same 1/2 that we got before. Probability doesn't change just because we rolled 10 heads in a row. Probability of an 11th head after 10 heads is still 1/2. So the answer to that last question, it's 1/2. Okay. It is still a 1/2. And I'm going to stop the video here, and the second video will do the rest of the examples.